there, this is Dr. May. I wanted to take a minute to just go over some basic ideas as like a last minute review before you jump into the Unit 2 test. And I want to start with this parallel lines and perpendicular lines. So we've talked about in this first unit that lines are a basic term in geometry, but we added a little depth that we brought back from algebra. And I love the two comparisons here. You see the parallel lines, those are two lines that never touch. They always stay the same distance apart from each other. And we, like I said, have dealt with this in Algebra 1, but in geometry, we're going to do a lot more with these parallel lines. Now, in contrast, the perpendicular lines, those are going to be the lines that form a right angle. So they do intersect, and they intersect at what I like to think of as like a perfect corner. But that specifically is a 90-degree angle. So I want you to have this fresh in your mind. Parallel lines never touch, but they always stay the same distance apart from each other. Perpendicular lines do intersect, but they do that at right angles. Let's look at our next idea. I mentioned the undefined terms in geometry, and remember, undefined terms, no definition needed. We don't try to write a definition for a point, but instead we explain the undefined terms using examples or illustrations. We show you what a point might look like. We tell you how to name the point. And remember, the examples of undefined terms in geometry are point, line, and plane. Now, if we look at that in contrast to definitions, definition is a statement that explains a concept or an idea. And we've had several of these definitions here in our first unit, in Unit 2. An example of a definition might be something like collinear points are points that lie on the same line. So in this sentence, we explain the idea or the concept of collinear points. So in geometry, we have some undefined terms, point, line, and plane, no definition needed. All we have to do is explain them using examples or illustrations. And then we also have definitions. This is where we write a statement that explains the concept or the idea, and we have an example of that as well. Okay, our final idea that I want to review with you is the idea of our triangle inequality theorem. That's a lot of words to say that two sides of the triangle must add to more than the third side. So what I have here in this puzzle is there are 12 sets of side length trios that form a triangle. In fact, I've already circled the first one for you. 12, 10, and 3 all form a triangle. Let's double check those sums to make sure. So we'll take two sides, 12 and 10, and that, when I add them together, must be more than 3. Well, of course, 12 plus 10 is 22. That is greater than 3. Okay, then you've got to check another set of 2, 10 and 3. So 10 plus 3 is greater than 12. That's right, because 13 is greater than 12. And then finally check the last group, 12 plus 3 is greater than 10. And that's right, because 15 is greater than 10. Now, what I'd like you to do is just pause the video, see if you can find the other 11. Now, the instructions here say you can find the trios horizontally, vertically, or diagonally. Okay? So I just want you to go through and practice with this. See, can I add two of the sides together and get something larger than the third side? If I can, and it happens with each and every one of the two sides, then it is forming a triangle. All right, my friends, I hope this helps you on your Unit 2 test. Good luck. Bye for now.